process now, and then I will hand the controls over to you, John. So take it away.
So hopefully people are seeing the slides starting to come in.
I see them on my end, so I think you're good to go.
Okay. So we're going to be going through getting the most from the Informix compression and other storage optimization features. I'm John Miller. I'm the product architect for the Informix products. And the first subject we're going to go into today is storage provisioning. Storage provisioning is fairly new, and it breaks a lot of the common thoughts we have about our chunks and our DB spaces, and a lot of the limitations and capabilities have been extended. So really, what is storage provisioning, and how do we work and act upon storage provisioning? Really, storage provisioning has two modes. You know, a proactive mode, which is going out and saying, I want to look and find that space is running low and go ahead and add space ahead of time and do this automatically. But there's always a window between when you look and when you need the space. And so there's actually a reactive method as well, which says, I ran out of space, but instead of returning an error to the user in the application or large batch job, I want to put a small stall and go ahead and allocate space and then continue the operation. So the only thing my users really notice is basically a slight stall in their application. You know, maybe a half a second or something like that to go ahead and get the space and assign it. So that's really both the proactive and reactive methods, and we'll go more into those in details in a few slides. The other thing that's changed kind of with storage provisioning is most customers are either using raw devices or cooked files. Historically, you know, we push those two methods and really encouraged, you know, raw devices when you want the hardcore performance, but cooked files really do a decent job also and have some simplicity behind them. One thing that came along and has been added with storage provisioning has been directories. So now we can go ahead and provide the storage provisioning in the directory and let the files all be created in that directory for you automatically. And we'll see a little bit more on that in a few slides also. So that's really some of the new basic concepts behind storage provisioning. There's a few more we'll see in future slides, but those are the real core pieces that we're adding to there. So what are the benefits behind storage provisioning? The basics behind storage provisioning is to eliminate the out-of-space errors. The out-of-space errors are, you know, something that generally cause a lot of problems to embedded systems or systems with very few DBAs. So right now, when we go ahead to expand spaces, currently we add additional chunks to those spaces. We are going to be able to manually expand spaces and automatically expand spaces without having to worry where that space comes from. And that's really going to be the policies behind storage provisioning. Also, the automatic expansion of DB spaces, temp DB spaces, smart blob spaces, temporary smart blob spaces and blob spaces. Those are all part of storage provisioning. In addition, the Open Admin tool, or OAT for short, which is the graphical administration tool behind Informix now, has this feature fully incorporated into it, and we'll see some slides for that here shortly. There's really two ways to do most, if not all, of the storage provisioning functions. There's two modes available. You can have it done manually, where you as a DBA can say, go ahead and do this action, or you can have it set up to go automatically. Put the policies in effect and then just have it run automatically. One thing we're used to here is two available space expansion methods. We're used to chunk creation when adding space, but what's new is a chunk extension. So now in 11.7, you can extend an existing chunk instead of having to add another chunk. That's something that's a little bit different to our previous core kind of methodologies. And there's really two ways to control all of storage provisioning. One is through the sysadmin database, the task and admin functions, and the second is using the Open Admin tool, or OAT, the graphical administration interface. So, one of the first things we really want to do is talk about the concept of a storage pool. There is one storage pool for all databases, and each instance of Informix has one storage pool. Regardless of how many databases or anything like that, there's one. And the storage pool is basically a place where you will tell Informix, your database server, what are the additional devices, chunks, directories you'd like to use when the system is running low on space. You can change these on the fly, you can add to them, you can delete, you can empty it out. All these things can be done, and you would use the sysadmin database and the task function in there, and you can see there we have the storage pool add, and we're adding the file work, DB spaces, DBS1, and we're telling about the size and what so it's the offset 0, size of 1 gigabyte, use a minimum of 100 megabytes in a piece, and give it a priority of 1. So a high priority. So this is adding that space into storage provisioning. Now when any of our chunks or DB spaces run low on space, we can go here and utilize this space as an option. There's still other options available, and we'll see those. So what does this look like in OAT? Well, there is a storage provisioning screen, and in the storage provisioning screen, it's kind of broken into a few sections. The top section gives you a lot of status and actually allows us to configure the proactive, there it is, the motion's coming in. Up on the top right, we can configure our proactive policies or our automatic policies. Here, we're basically saying we can enable automatic expansion proactively. We can set up a free space threshold, whether it's a percentage or a physical amount of space. And when we get below that threshold, we'll go ahead and enact the policies that we've set up. And we'll talk about those policies. So on the left is a summary of the space left in the storage pool. So you don't have to go down and figure out which storage pool devices are used and have no space left. They're right there in front of us. So we have some fixed length entries, and of the fixed length entries, we have 10 megabytes left. We also have devices that are expandable, that are not of a fixed size, that we use them until those devices or directories are full. And once they're full, we will not use those directories anymore. And those are extendable entries. So we have 2 of those put in place here. Now down at the bottom section, those are all the devices or directories or cooked files that are put in the storage pool. There's a lot of status, you know, how much space is remaining, is it full, what's the priority. You can add, delete, and modify those devices at any time. So while the system is online and operational. So we have talked about this, that chunks are now extendable. So if you have a chunk that's 1 gigabyte and you'd like to grow it, you can now grow it to 2 gigabytes. You can set this to happen automatically, or you can do it manually and force it. To stay compatible with your current behavior, if you do upgrade or you create a chunk without saying the expandable option, by default, chunks are not expandable. So if you upgrade from 1110 or 1150 to 1170, where you have the expandable chunks, all your chunks will not be expandable. There is the command, the top red command, execute function task, modify chunk extendable on, and you provide the chunk number. That will indicate that that chunk is now expandable, and when it runs out, it will grow. You might not want to wait for it to run out of space. You might want to extend it right now. So then there's the second command, which says modify chunk extend chunk 27 by 2 gigabytes. So that will grow that space. Now, if you extend chunks and do that work, that is not taking space from the storage pool. That is using your existing chunks. The only little caveat there is if those are cooked file chunks and they exist in the same directory that you might have in the storage pool if there's a little bit of an overlap. But they will not take space away from fixed length entries in the storage pool. So, you know, extending chunks is, I think, a great new feature in itself added to version 11.7, and so I think that's something that you know, everyone should consider looking at, because you know, having the chunk screen roll and having to look at lots and lots of chunks can be you know, an issue or just a little bit of a DBA. It makes more work for the DBA. So great new feature there. Now, if we go into OAT and we look at the chunks pod and we see the list of chunks that you have, you'll notice some new fields and columns and new actions. One of the new fields right away is the extendable column, where there's some red X's and green checks. And you'll notice that some of those chunks are marked as extendable. And one of the other things is the highlighted chunk will show a fragmentation map to show how fragmented it is. What it's really getting to is the actions. You know, in the past, we could add a chunk or drop a chunk, but really modifying and extending a chunk are new actions for chunks. You can modify different attributes. The extendable one is one of the attributes. And then, of course, you can extend a chunk. By extending a chunk, we force it to grow right here, right now. So those are new actions that, really we didn't have before. And before it was add and drop. So expanding a storage container, and I'm using storage container for short instead of having to say DB space, temp DB space, smart blob space, temp smart blob space, temp DBS, and blob space blob. It just gets really long, so I'm lumping those and calling them storage containers. On the storage container or on the DB space, you really specify the policy on how those DB spaces and chunks can grow. You can set it up for all manual, which is generally how it is. If you upgrade, everything's still set to manual just the way you have it. Or you can set it up to be completely automatic. All the policies are set up ahead of time. When the system comes up and says, okay, I need more space, you've pre-configured all the policies. You're able to determine exactly what was done and what policies were set up, and then the system will take the appropriate action. So the other thing that I see that this is really nice is generally when you run out of space, it's not at 3 o'clock in the evening when you have nothing going on and the system is running. It's usually at 2 a.m. in the morning when operators are tired, maybe not concentrating as much, and then you have to go look up where's the space, where do I get it from, how do I assign it, do I check it out and record it properly so the next person knows that space is used. So here you can put those policies all in effect ahead of time, during the day, in the planning time, long before you run out of space, and have those policies acted upon. So, this concept of a storage provisioning is really allowing you to set those policies. Now, when we set those policies, we determine first if any chunks are expandable. So we expand chunks first, and then if there's no expandable chunks in the DB space, we will add a new chunk to that DB space. So we try and minimize the number of chunks created if we can, if there are expandable chunks in the DB space. If not, we have to add a new chunk to that DB space. So one of the things that we have here is we can look at the spaces. We're showing the DB spaces and smart blob spaces and temp DB spaces and all the different spaces that are on the system. And we see right away which spaces are expandable and which spaces are of fixed size. And we should notice that in the columns on the right, let's see if we can use our pen here. The columns over on the right, we have expandable, create size, and extend size. So when you set up the policies for these spaces, if you are going to create a chunk, you want it to be at least 10% of the current size. If you're going to extend this chunk, you want it to be, for the first entry, 9.77 megabytes. That's the minimum size you'd like to grow that space by. So when we extend, and you notice that the first entry is 9.77 megabytes, where the second entry is a percentage, 15%. So if we are going to extend DBS1, we are going to grow it by 15%. if we're going to create a new chunk, we're going to create that chunk at a minimum of 10%. So right here in the storage pods, you get a great view of a summary of the policies that are set up for the spaces. So one of the nice things is, if you do hit expand, you get a simple screen brought up that says go ahead and expand the space. So I'm going to and it's pre-configured based on the policies that you have set up. The command's listed down at the bottom, so you can see the SQL command that will be run. And it's basically simple. I'm following the policies. If you want to click the Advanced tab, you can go ahead and get a more advanced screen and basically dictate to the system. You can change the percentage. Currently it's set at 15%. Maybe you want to make it 25%. We list the current chunks in the space, which ones are expandable, so you see all the reference. Or maybe you just say, okay, I don't want to expand it. I want to add a new chunk to that. And here is the path and offset. So all the options are provided right there in both the simple and in the more advanced screen. Another thing that's really nice is when you go to create new DB spaces or to drop DB spaces or smart blob spaces or any of the storage container types, you can create new DB spaces from space allocated from the storage pool. So if you've configured your storage pool to have a few of your chunks, or sorry, a few of your raw devices, cooked files, or a directory in there, you can say create DB space from storage pool, and I want it called orders DBS and be of 100 megabytes. That will go ahead and allocate the space from the storage pool and create that DB space. Just like you can create a space, you can actually drop a space and put the freed up space back in or back to the storage pool. And that's drop DB space to storage pool DBS1, or the name of the DB space. That way, this DB space will be freed. You won't see it anymore, but the space and the devices used will be put back in the storage pool. So that is really, a quick overview of a lot of the features in the storage pool realm. There's pieces of it you can use, whether it's just proactive allocation, whether it's I just want extendable chunks. There's a lot of different pieces. You can use all or part of it depending on the needs of your system. But there are a lot of different pieces in there for DBAs to utilize, and we're really working on avoiding all the downtime and all the late night DBA work to create and add spaces and think about and eliminate mistakes. And eliminating mistakes is where we're going with the next feature. I call this the save your company feature. It's kind of the oops, did that really happen? It's a short one here. And this is to prevent accidental disk initialization. I'd like to say this never happens, but every so often we get customers calling in saying, I accidentally just reinitialized my disk, can you help me? And I'm sure for everyone that gets called into support, there's probably a few of them that don't call into support. So there is a new onConfig parameter, and it's called full disk init. And it has two values, 0 or 1. And so if, when you go to initialize your system, if we recognize that the page and the beginning of the root DBS was previously used or is in current use by Informix, we will not allow you to reinitialize the system. Now, how do you get around that? Well, you set the full disk init onConfig parameter to 1. That says always initialize the system, even if I recognize that there is Informix there. Now, as soon as you set that, as soon as you do initialize your system and you write the new markings, and Informix is brought up, we will set that parameter to 0. So that parameter will be set to 0 after an on-init IY, after the system's been initialized, thus preventing an accidental disk reinitialization. And we will, if you try an on-init IY with it set to 0, you'll get a message in the log saying, we won't allow you to do this because we recognize that there is a, current Informix markings on that page, and we're just going to, prevent you from doing the work until you really override it. So hopefully this helps a few people out. 1 or 2 people a year would, if we can eliminate those, we've done a great job and, help our customers out. So that is the, save your company feature. It saves them downtime, saves them having to do a restore. So we talked about storage and configuring and setting up and automating it, and accident prevention. Now we're really going to move into the optimization of the storage, and so we're going to see a lot of the things that we do there. And as a DBA, we hear a lot of things that people have to do. The first one is reduce the number of extents a table contains. Now, this is kind of a, 11.7 went a long way to helping DBAs not have to do this by putting in many optimizations and extending the number of extents a table has to, tens of thousands. I think it's up to about 30,000 or so. So the limit of 180 or 200 or whatever it was is long since gone in 11.7. But there is, some thought to just keeping the extents reasonable together, keeping your data coexisting in a, similar or adjacent, extents. So you kind of keep it packed and it works on it a little more efficiently. And so reducing the number of extents a table has. The other thing is, if you typically delete a lot of random data out through your system, or you do a lot of purging and you purge the data out that happens to sit physically at the beginning portion of the table, you have a lot of free space you'd like to reuse. So, moving all the rows that are interspersed throughout your whole table back to the beginning of the table. And once you've done that, you have a lot of free space at the end of the table. And you'd like to return that free space from the table back to the general system so other tables, indexes, or objects can utilize that space. So all of those things are done. And, you want all that to happen while the system is online, because we don't want to have to take the system down. We want to be operating on the system, working on it, and you want to do that all while watching your favorite TV show. So you want to say, here's what I want the system to look like, walk away, and the system does all the work. So let's look at how we accomplish all that. We've really introduced a lot of new functionality through the last couple releases in this area. With 11.7, we have the online defragmentation of extents, which really is combining two extents into one, thus reducing the number. And when you keep combining, multiple extents together, number gets lower and lower and lower. Might not always go to one based on the system space and how things are allocated, but it takes it from many extents down to fewer extents. Next, we have data compression, and this is really in-row or in-table storage, and it's really there to reduce the amount of space a single row takes. So if the previous row was 600 bytes, we would drop it to, say, 250 bytes, compressing that row. And next is the table compaction. This is, we talked about, now that we've really compressed all those rows, they are still in the same page they were to begin with. We want to take all those rows and move them to the beginning of the table and free up all the space and put all that free space at the end of the table, packing all the rows tight. And so that's table compaction, and we'll go into a little more detail. Index compaction is a way of actually keeping sure index pages are full, and there's some ways of changing the thresholds on that. And lastly, you want to apply policies to your tables and have those policies carried out automatically. So you don't have to go ahead and say, okay, this table is now 70% fragment. I want to run table compaction on it. So let's really drive into each one of these features. And, needed to point out, the data compression feature does have a separate license and charge for that portion. But that is just the data compression feature. The table compaction, the defragment extents, does not have an additional charge to utilize. So, a lot of times we've had people lump in the online defragment extents or the table compaction into compression and say, I can't use those because there's a charge. That is not the case. It is only the data compression for which the charge, the additional license is required. So when we go ahead and optimize table extents, we can see we have our big DB space 1 on the right side. And there are different table extents represented by different colors. So we have the customer table in blue, the orders table in orange, the items table in green, and the products table in purple. And they're interspaced through the whole system. And then we have some free space down at the bottom or end of our DB space that's in red. So what we're going to actually do is while people are inserting, updating, and deleting to this table, we are going to move the extents to some free space, combining the extents into one extent. And we are actually going to go through this in motion so you can see this happen. So when we start, we run the command defragment, and we provide the database and table name. So we're going to start defragmenting the customers table. And currently there are 5 extents. So when we execute that, the first thing that's going to happen is the customer 1 extent is going to be moved to the large free space at the bottom. Then the customer 2 extent is going to be moved. They're now physically adjacent, so they're going to be merged into one extent. Then we are going to reassign the numbers, 1, 2, 3, and 4. So now we only have 4 extents. After that, we're going to move the new extent 2 and put it adjacent to our new extent 1. Merge those extents, making a larger extent 1, and renumbering. So now we have extent 1, 2, and 3. And after that's done, we actually stop. Why do we stop? Because there's not enough free space in our DB space to put any 2 extents of the customer table adjacent to make one larger extent. So that's why, yes, we can reduce the number of extents, but it doesn't always go to 1. And the reason is, it depends on how much contiguous free space exists in the DB space that the table or fragment it is in you are trying to defragment. And again, you can drop, unload, drop the table, recreate it, reload it, reindex it. All that can be done, but that takes, downtime and the table's inaccessible. This can be done while people are online, updating, deleting, and selecting from the table. So a big win for all. So in OAT, there is a tables and indexes pod which you can go to and view and take those actions right on this table. So you click on the storage, and then that will go ahead and you'll have to look at the tables and indexes and expand that mini pod into a larger screen. And then with that screen, it will bring up each table and index that exists, and you can see the top table, cars, actually shows there's the red under space usage and the pink with the arrow. And the pink with the arrow estimates how much space would be saved in that table if you were to compress it. And then you can go ahead and optimize that table. And you can choose to compress it, repack it, shrink it, and defragment it. You can check all of those to happen at one time on a single table or group of tables, and then those actions will be carried out in the background because those actions don't occur instantaneously. They do take time. So the next operation is to actually compress a table or fragment. And there's a lot of benefits to compression. And I originally used to think that compression was really just targeted for large systems. And we've done work and shown a great benefit on small and medium systems, especially when the data, the common set of data, didn't fit in the buffer pool. And now by moving that data into the buffer pool, or moving more of that active working set into the buffer pool, it's a great way of increasing the read cache ratio, and things like that. It benefits archives. It benefits if you have long or forwarded rows. And one of the other benefits that a lot of people don't really realize right up front is if you're running with HDR or mock or some form of replication, the data that's placed in the logical logs is actually in compressed form. So when we log those records, if you insert 100 rows and each row is 100 bytes, that becomes 10,000 bytes of data you put in. If they're actually compressed and we get a 50% compression ratio, instead of 10,000 bytes into the log, that's 5,000 bytes. And then that 5,000 bytes is sent across your replication network. So it could be a 50% reduction in your HDR or replication environment when transmitting data, so a big savings there. How we actually go and enable this is using the admin API, the task or admin function, and say compress table and a table name and database name. And that will go ahead and compress a table. Now let's really, and that, it's pretty simple. I think we're all used to that. That will go take a row and shorten that row. If that row in our example was 100 bytes, it becomes 50 bytes. Now, the issue is those rows do not move. By the compression, they still sit on the same page. So what we need to do is a second command after the compress, which is called REPACK. And this is also a great command to run after you've done large purges or massive updates, things along those lines, where you might have moved data around and left a lot of empty holes in your table. So the REPACK table command is similar to the compress command. You say table REPACK, customer and database, and we have a look of a customer table there, and it has green holes and it has some red rows. And the beginning of the table is up at the top, and the bottom of the table has Steve and John. And when we start running the command, what happens is we delete the row from the end of the table and reinsert it at the beginning. And we basically start packing and moving data along, and that continues to happen until we basically find that all the free space at the beginning of the table has been consumed and we have nothing left at the end of the table to move. So once that happens, we stop, and now you can see we have a nicely packed table at the beginning and a lot of free space at the end of the table. So that is what the table REPACK command does. It really packs that table up tight in front. And then lastly, we have the shrink command, the table shrink. And the table shrink command is really intended to take that free space off at the end of the table and return it to the system. It can take partial extents, it can take entire extents, but it's really taking that free space off at the end. Now, if you want to say, I want to reserve some free space at the end of the table, the shrink command will not shrink less than the first extent size. And the syntax alter table modify extent size has been added to allow you to adjust the first extent size if you need to. But if we just run through our example, when we go to run shrink table command, it takes the free space off the end and sends it to the system. So our table size and the number of pages to our table is now fewer, and it's all packed tight, and you're ready to rock. Now, the last thing that we had in our goal was to do this automatically. And there is in OAT an admin task that runs, and you can enable that task, and you can enable various parts of that task to go ahead, and you can enable compression. And you'll look for tables or fragments who have over a set number of rows and automatically compress those tables. You have the REPACK option, which will look for tables who have discontinuous data in the amount of 50% or whatever percentage you want to set, and then we'll repack those tables. Shrink. If 50% of the table is unused, we'll shrink that table. And then lastly, if the table has over 100 extents, we will attempt to defragment that table. And then you can specify at what time of day and how often this task should repeat and what days of the week. And you can enable those policies. They get updated, and then they're automatically in effect for your system. So that's a way of really setting up these policies ahead of time, just like you did with storage provisioning, and having them acted upon. So we're coming down to the home stretch, and that was really a lot of the storage provisioning. And now we're going to go into the last section of the talk, which is just a few index optimizations that have taken place. And one of these has been, I think, on the top list of the IIUG feature request list for a while here, and that is the ability to create indexes with specified extent sizes. So now in 11.7, you can go ahead and create an index and use the extent size and next extent size. And it basically will set this, allowing you to control the utilization. If you have odd number of duplicates or things like that change the extent size, the default extent sizes don't work well, you could make that. Utilities such as DB schema will report this. And in general, the default size is really the index key size to the data row size times your data extent size. So if your initial extent is 100 meg and your index size is 10 bytes and your row size is 100 bytes, you're going to take 10% of your initial data extent as your index extent. Now you can go ahead and create the extent of whatever size you want for that index. So that has been a big, big win, and been, something our customers have requested. So hopefully this helps you out in moving forward. Another index enhancement is really had to do with constraints. And we enforce constraints with an index and utilizing an index. And sometimes you don't want to do that. If you have a small child table that has 4 rows, and all 4 of those rows fit on one page, why create another index to look up the rows just to go back to the one page? You might as well do a sequential scan and read one page from disk instead of maintaining an additional index. So that has the ability, you now can say index disabled when creating a constraint, and that will not create the index when creating the constraint. So one of the things we've also done is there's a new index type. And we're going to traditionally, we're going to look just at what we have right now, and what most people generally use is a B tree. And a B tree has one root node, and then it has twigs and leaves, and we could have a 2 or 3 level index or many level index, but there's still one common thing in the B tree, and that is the root node. And then any time you access an index, you will always be going through the root node and finding out where to go. If you have many, many users and they're all accessing the index at the same time, even if it's in read-only mode, just the act of accessing that single page with all these multi-core, multi-node, cache level 1, cache level 2, NUMA architectures, all these types of things creates contention. And so there is a new index type called Forrest of Trees, and that Forrest of Tree breaks some of the traditional B tree indexes in that it creates multiple root nodes and doesn't have to have as deep of an index, because we really hash out the first level of the index. So the index will have many small subtrees and many root nodes. And this is really there to, one, reduce the depth of the index and also to reduce the contention on the root node when you have, lots of concurrent access to that index. Let's really take a look at what that index would look like. So we create an index just like we would, but we have new syntax in blue which says hash on. It could be a single column, it could be a group of columns, and then we create it with buckets. And we could say 3, we could say 100, we could say whatever number of buckets. And that breaks that index to have multiple root nodes. You can see we have bucket 1, bucket 2, bucket 3. So we really have many subtrees. And the contention is spread out. So not all users are accessing and always having to go through the same node. Some B-tree functionality is not supported, and it's really when you hash on C1, C2, you're really looking for equality operations on the item you hash on. So greater and less than and things like that really won't come into play here. So you really need to use that equality predicate on the column you are hashing on. And all of the utilities, have been updated. One thing you will notice when you run an onCheck PT and you're looking at the levels, if you have a traditional B-tree index, level 1 always has one page. Well, in this onCheck PT, level 1 has 100 pages. That means we have 100 buckets or 100 subtrees. Where do you find out how many buckets and the hash columns? Well, that is in the sys indices table. There's 2 new columns called n hash calls and n buckets. So those will really represent how this new Forest of Trees index was created. So with that slide, we've really come down to the end of our talk, and I want to thank you all for being a part of the talk. If there are questions, I went and looked at the QA panel to see if anyone has posted a question to the group, and I don't see any. I'd be happy to wait a minute if people are typing or...
Yeah, John, this is Tom. It looks like we do have a couple that have come in, and also I've had a few people ask me individually for the slides, and I'll make sure I send these out to everybody who attended today when the presentation is over.
Okay, Tom, I don't have any messages on my...
Oh, okay.
So they might have just sent them to you instead of to the entire group.
Sure. So if you could also turn off desktop sharing there, John.
Okay.